Hello everyone, welcome back to our next lesson. We're still on inverses. I think we can finish up the topic of inverses with one more video. This part begins on page 27 of your notes, and it says, graphically verify an inverse. You see, there's a certain special relationship between the graph of a function and the graph of its inverse. Now, I wish they had a blank piece of graph paper here somewhere, but what I'm going to do, I'm just going to go back a few pages. I think on page 16, I've seen a nice graph there. I'm just going to show you a little example. Okay, here we go. Here's a blank piece of graph paper. This will work fine. This will work beautifully. I'm going to show you a certain relationship between a function and its inverse. So what I'm going to do, let me just take my marker here. I'm just going to pretend draw some function, okay? Now, I really don't even know if this function really exists, but I'm just going to, let me get my red marker. Okay, so what should I going to do? Let's suppose I got a function that starts there, goes through there, goes through there, and goes through, where else? Let's say right here, this point, okay? So I'm just going to draw a curve going through those points right there, all right? Now, that's some function f of x. And I don't even know what that function is, and it doesn't matter. If I gave you this on a quiz or a test, and I have given this question before, if I said, here's a graph of some function, I want you to go ahead and draw the graph of the inverse. I want you to see how easy it is, and that will clearly show you the relationship between a graph of a function and its inverse. So here's what you do. Now remember, you don't know what that function is, but you can look at it, and you can clearly see some points that are on that function. So for example, this point right here, look at that. I just slapped it down sort of randomly. It looks to me like it's -4 and -1, isn't it? -4, -1. That's on the graph of f of x. Well, let's find the other points. This one right here. What was the coordinates of that? Well, that was -3, +1. Okay. Now remember, I just slapped those down. The next one looks to me right here. That looks like the point 0, 3. Okay. And then finally, I can see this point right there. And that looks to me like it's the point 6, 5. All right. So there's 4 points that are on the graph of the function, f of x. Now, watch this, everybody. I don't know what the function is, but you know what? I can easily get some points now that go on the graph of the inverse. All I do, remember, is take the coordinates of my points that are on the function and switch them around. Remember, the x's become y's and the y's become x's. So let's get some points that are on the inverse. Instead of -4 and -1, that's on the original function, -1 and -4 will be on the inverse. Okay? Well, another point on the original function was -3, 1, so I guess 1 and -3, that's going to be on the inverse as well. 0 and 3 was on the original function, so switch them around. 3 and 0 must be on the inverse, and 6 and 5 is on the function. Switch them around, so 5 and 6 must be on the inverse. All right, now like I say, I have asked this question on a test before, and it's very, very straightforward. Now, plot all of those points on the same graph paper, on the same sheet. Watch what happens. -1, -4 will end up right there. Look at that. See that point there? There's -1, -4. 1 and -3 ends up right there, approximately. 3 and 0, right here. And 5 and 6, well, I can't quite see it, but it's about right there. You see that? Just above that part of the graph. Now remember, this is where it starts. This is where my graph starts. So watch what I get. See that? So if the red graph is the function, the blue graph is the inverse. Now, they're kind of alike, aren't they? They're kind of shaped the same. And that shouldn't be surprising. the fact that they're shaped the same. In fact, one is a mirror reflection of the other. And where would you place the mirror to so that one piece, one of the graphs, is reflected into the other graph? Well, in fact, you'd put your mirror, it's kind of like a line of symmetry right through the middle of the two graphs, like that. There's your line of symmetry. That's like your mirror. And if you look at that line, that equation, if you were to get the equation of that, well, let me see. It's got a y-intercept of 0, and the slope is, let me see, it goes through that point there. The slope is 1 over 1. Well, that's a slope of, that means the slope is 1. So that equation is y equals x. Very simple equation, isn't it? Y equals x is your mirror. It will always be your mirror between the graph of a function and its inverse. And that shouldn't be surprising, you know, y equals x, because remember, the y's become x's and the x's become y's. They're kind of the same, aren't they, in that mirror? Now, that little property right there, that a function and its inverse will be a reflection of each other in the line y equals x. It's always the line y equals x is your mirror. That, if we now kind of fast forward, is what they're trying to get you to see here on page 27. All right, 25, 26, right here. Graphically verify an inverse. They're asking you to graph two functions. And if one of those functions is a reflection of the other function in the line y equals x, well, that must mean they're inverses of each other, okay? And that's what we're going to see. And that's what it's explaining right here, by the way. Let me change my marker again. That's what it's explaining right here. We can verify an inverse graphically by plotting the original function, the inverse, and the line y equals x on the same axis, right? It has the property, the inverse has the property, it is a reflection of the original through the line y equals x. And when we plot all three of them, we should note that the function and the inverse are symmetric to the line y equals x. So let's go ahead, let's play their game, eh? Let's try this, why not? So here we go. Here's one function, f of x equals the square root of x plus 1. Now you will note that they have made a very small table of values for you to put these numbers into. All right. Now if you do so, if you put in -1 here into the function, you're going to get -1 plus 1. Well, that's 0, and the square root of 0, that gives you back a 0. If you put a 0 in for x into f of x, you get 0 plus 1 is 1. The square root of that, that's 1 as well. If you put in a 3, 3 plus 1 is 4. The square root of 4 becomes a 2. Now, you can plot those points right now if you wanted to. You see, look, -1, 0, 0, 1, 3, 2. So -1, 0 would be right where? -1, 0. Right there, look. There's -1, 0. Now, draw this with red ink. 0 and 1 is right there. And 3 and 2 would be, now be careful because they've scaled the x's. There's your 3 and 2. Now, it actually starts over here at -4, all right? And it kind of looks something like, oops, a little bit there. There. There's your function f of x. Okay, it looks okay. That's the general shape, by the way, of a square root function. Okay, like that. Now, let's go to the next one. I can see it's a parabola. Ooh. Now, the only thing is, we can only graph half of it, right? So we won't graph anything less than 0. I'm thinking we'll have to restrict the domain to greater than or equal to 0 here. And I'm going to use blue ink for this, because I kind of like blue. So if I put a 0 into this function now, into g of x, put in a 0, you get 0 squared minus 1. That gives you -1. So look, there's one point you can plot on g of x. Put in a 1, you get 1 squared is 1, take away 1. Okay, that gives you back a 0. Plug in a 2, 2 squared is 4, minus 1, you get back a 3. All right, so plot those 3 points now. 1 and 0 would be, or sorry, 0 and -1, I mean, is right there. Look, that's the starting point. That would be the vertex of the parabola, but remember, we had to restrict the domain. 1 and 0, right here. 2 and 3 would be right about there. And now watch what happens when I draw that. Look, see that? So that is the function g of x. And now the question becomes, are those two functions inverses of each other or not? And the answer is, by golly, they sure look like reflections of each other, don't they? In the line, and here's your mirror again. Look, y equals x. It's always y equals x for your mirror. Well, yeah, they kind of look like reflections, and they are. And in fact, if you look carefully at the table of values here, these points you just created, you can see that they're just each other flipped, aren't they? Like the x's and the y's flipped over. That's all. That's all that happened. And so your conclusion would be, so f of x and g of x are inverses of each other. Because they're a reflection in the line, they're symmetrical about the line y equals x. All right? So now you try the practice one after that, practice number 13. Here you've got f of x equals the square root of x plus 5. Okay. G of x is equal to, now that one might be a little tricky. Not too bad, though. X squared minus 10x mod plus 25. Now remember, you would have to restrict the domain there. Wherever your vertex is, only keep half of that. And the line y equals x on the graph below, verify that the function g of x is actually the inverse of f of x. So the same basic thing should happen as happened here in example number 13, okay? All right, so that's it for today. I'll get you to do that. Our next lesson is going to be on something called reflections. We're going to be looking at symmetry and reflections and translations and things like that, okay, about functions. So I'll stop there, and make sure you try the practice questions that I've assigned. And if you have any trouble, you let me know. Bye-bye for now.